Hey folks, Brandon Villarolo with the Register, and today I'm speaking to Endor Labs founder and CEO Varun Badwar about software supply chain security and why that's become a huge threat lately. Varun, thanks for joining me.
Brendan, great to be here. Thanks for having me.
Yeah, of course. So, it seems like software supply chain stuff is in the news more and more often recently. We got big hitters going back a couple of years like SolarWinds, Log4j, Move It. And like I even just wrote last week about, an India-based antivirus company who had their definitions updates hijacked to deliver crypto mining malware. So like, right, it's everywhere. Are we it's tempting to see these kinds of uptick in stories as an actual rise in these sorts of attacks. Or is this just, since SolarWinds and things, are we more aware of this issue? And has it always been a problem?
It's a great question. I think SolarWinds certainly was a wake-up call for the industry. And I think it was
Mm-hmm.
also a wake-up call for the attackers to say, well, when you're looking for the easiest path into organizations, the software supply chain might be one. And I think bringing all of those things together, it certainly is clear to me that software supply chain is going to be the next frontier of cybersecurity and cybersecurity attacks. And I think if you look at the US government's interest and participation on this topic, I'm sure
Mm-hmm.
they usually have, are seeing a lot more earlier indicators of this. And the fact that, the executive order that started out from the White House a couple of years ago to continued momentum behind the Secure Open Source Act that was introduced into the US Senate and just the continued momentum and enforcement around software bill of materials, it is pretty clear that we all as an industry need to pay a lot more attention to software supply chain security.
Yeah. Now, speaking of, you just mentioned open source, which is actually going to be one of my next questions, right? And that's I think something I hear a lot in conjunction with software supply chain security, right? Because I think a lot of people, both in the industry and outside, right, assume open source means anyone who wants to can simply grab and modify this master channel of code. Well, that's not
Yeah.
necessarily the case, but still, are open source projects, are they actually sort of the major weak point in this, or are they just like an easier target?
Brendan, actually, I think it's both. They are the easier
Mm-hmm.
target, but they're also the most prominently used in your code. So let's look at some data and statistics, right? 80 to 90% of modern application code is open source. So
Right.
when you're using that much code from complete strangers on the internet that you know nothing about, and generally and historically, there's been this implicit trust in the open source ecosystem, kind of the do good type of mantra. But here you are now where the attackers are looking at this and saying a developer in a large enterprise, a regulated enterprise, would go to the same place as a startup would, which is to GitHub or NPM or PyPy, and
Mm-hmm. Mm-hmm.
grab code that they just don't know a lot about and bring it into their critical infrastructure, critical applications. So with that volume of code, and fundamentally what I believe, Brendan, is with AI and AI assisted coding, guess where a lot of these AI models are trained on? Also open source. So,
Mm-hmm.
I believe the numbers are going to go from 80 to 90% to maybe 95, 98, 99% of your code in an enterprise environment would be written from basically untrusted, unvetted sources. So absolutely, I think this is the frontier also within software supply chain security of attacks.
And I think that raises, AI to me raises a really interesting question, right? Because like, one of the things that, like you mentioned earlier was software bill of materials, right? Where there's these records of who's done what with what in what step of the process,
Yeah.
right? And that's pretty easy if everything, you know, is a human leaving a receipt behind saying this is what I did or this is what I pulled, this is what I added, right? AIs aren't exactly the best at citing their sources, right? Like, are we looking at you know, a potential for like software supply chain vulnerabilities to get even worse if AI starts writing these things because it's not telling you where it's pulling things from, and so you got mystery code in there?
Yeah, look, the way I classify AI's ability to write code today is it's an intern level, right? So whatever you get from there,
Right.
maybe you're spending 70% less time writing the code, but you better be spending 70% more time reviewing the code that's generated from the AI. So you kind of have a net neutral outcome today. Now, that doesn't mean a year, 3 years, 5 years from now, this doesn't fundamentally evolve. But
Right.
yes, like you're right. One is if it's trained on insecure code, you're going to have more insecure code. So that's certainly a danger. And there's
Yeah, and will
also
it be properly documented and
correct.
findable, right? Like, are you? Yeah, that's the
The
big thing that
provenance,
seems
right?
to
The
me. Yeah.
provenance of this, what you're getting into ultimately is how do I
Yeah.
know what was the source of this? And not only does that have a security implication, it also has a legal implication, Brendan. So am I taking copy left license code that I'm actually supposed to attribute to somebody and now just copying it in my environment? So there's lots of issues with that. But yeah, coming back to kind of SBOMs, I fundamentally believe it's a good step in the right direction, but there is so much work to be done behind this because if you think about an SBOM, let's just take, for example, the SBOM is a means to an end because at the end state, before you're about to ship your application, you produce an artifact that says your application has these 75 different open source or other components. Great. What it doesn't help you do is prevent bad code from getting into your application in the first place. So if you see,
right,
you got to shift this process entirely to the front. And what is the front? The front is when your developers are deciding and evaluating what code to use. I'm surprised we're 5 minutes into this conversation and XZUtils hasn't come up, but there you have it. Like, how do I prevent the next XZUtils or the next malicious code from being even downloaded by my developers? And in most organizations, unfortunately, today, it's a hope and pray strategy. Most of them have a paper-based, recommended guide that says, if you bring in open source, make sure it's high quality, make sure it's secure. But who's vetting all that? This is like Disneyland for developers. There's 47 million open source packages and versions out there. My developers want the latest and greatest. I can't slow them down. So how am I going to do all of this? There's conflicting priorities. And that's why we fundamentally believe you need to automate that entire governance and selection process and actually help your developers in that vetting process. And for example, at Endor Labs, we have built a whole engine that scans every package for, hundreds of different vectors of early signals of risk. And we think the industry needs more and more of that investment across the board.
So I guess that was going to kind of lead into my next question too, was, what do you think are some of the most immediate solutions for this, right? Automated testing obviously seems like a pretty viable one, right? That's not exactly the sort of AI that we're still trying to grapple with, right? That's pretty recognizable and easy stuff, right? If you've got snippets of code in here that look like they belong to something else that has a problematic history, right? We can flag that kind of stuff. I mean, what else besides, introducing automated tools? What are some things that companies can do to, or developers, that they can do to watch out and prevent these sort of things?
Well, listen, I don't want to marginalize that automated verification because the whole industry, 99% of the world today, all they're looking for is known vulnerabilities and license risks around code. The problem fundamentally with software supply chain security, Brendan, is the malicious code does not pop up as a CVE or a known vulnerability in your vulnerability database. So you need to go back and retool your entire organization looking at the top risks around open source. But the first question is, how do we educate the world on what are these emerging risks around software supply chain security? So, we worked with the OWASP and have launched a OSS top 10 risks report that had dozens of different CISOs and CTOs participate. So step one is education. Understand what are these next-gen attacks? What do they look like? How do they detect them? Step two is how do you then put automation in place to look not just for vulnerabilities and license problems, but malicious code or, mistyped or typo squatted packages or, signs that tell you that this package may be okay today, but 6 months down the road, you might cause you problems. So there's automation there. There's an element then of within an organization, you're looking at hundreds of thousands of packages at scale. And if you talk to most enterprises today, they can't even manage the vulnerabilities that are coming out of these packages. So you have an immense effort required around prioritization. What are the things you got to fix now? What are the things you can defer to next release? And what are the things that you can actually just kind of lay out to the side because they don't truly affect your software supply chain posture? And ultimately, like if you round all of this up with, it comes with visibility, know what your developers are bringing in, understand and prioritize the risk. Second is fixability. It's easy to say, hey, developers, you made a mess here, or you brought the wrong libraries or wrong code. How do I actually help them get to that next stage of fixing the code, which is really hard, right? So using AI, using impact analysis and assessment, how do I finish the last mile of remediation? And the last piece of all of this that rounds together is how do I make sure that SBOMs, which have a great intent behind it, ultimately have the right relevance and context so you can trust these artifacts when a producer of software shares that with a consumer of software to say, look, I believe and trust that these are accurate. And on the consuming side, how do I evaluate all of the information within an SBOM? Because there's a lot of things that an SBOM can tell you, most enterprises don't understand how to ingest and even analyze that information.
Yeah, I mean, a lot of work to be done, I'd say, right? And we've got how many years of software layered up now that hasn't had these kind of things done to it, right? So we've got all these, all this kind of, whenever we decide that this has got to be a thing, we got to prioritize, right? The whole world has to kind of stop, take a pause, and go back and analyze all of its existing kit just to be sure we're not overlooking stuff there too. So it's, if you had to predict, right, just in closing, how long do you think it would take with concerted effort for the world to really get its stuff in gear when it comes to software supply chain risks?
Look, if we draw an analogy to other industries within cybersecurity, network security, endpoint security, cloud security, it usually takes between 7 to 10 years to really get to the maturity level from, oh my gosh, like we weren't paying attention to this problem, to look, we as an industry feel confident that we've solved it collectively. So I would say, in baseball analogy, we're probably in the first or second innings of this, and we still have a long way to go.
Well, hopefully we can do it in quicker than a decade, because this is not going to become a smaller problem, I don't think. Yeah. So, yeah. All right, Varun, thank you so much for joining me this week, and good luck next week at RSA.
Thank you.